Yes, good morning. I'll come you to this lesson. We're going to capture continuous probability density functions. This is our mathematics paper 2 or applied math lesson. And we're going to cover part of the probability density functions, but this time continuous. So when we say a continuous probability density function, it's that density function whose domain is continuous. When we say that the domain is continuous, we can take an example of f of x equaling to a less or equal to x less or equal to b. Now here, x takes on any value within the given range. X can take on any value within the given range from a to b. Okay, so for your continuous function, continuous is the opposite of discrete. Okay, so for a continuous function, cannot say for a continuous function, probability of a less or equal to x less or equal to b is equal to probability of a less than x less than b. But majorly, we need to know the properties of a probability of a continuous probability density function. So properties of continuous probability density function, PDF. Property 1 is that f of x is greater or equal to 0 for all values of x. For all values of x, f of x is greater or equal to 0. B, the other property is that the integral from x is equals to a up to x is equals to b of f of x dx should be equal to 1. Okay? We shall see how we apply this. Or integral from negative infinity to positive infinity of f of x dx is equal to 1, meaning the summation of probabilities at different intervals should be equal to 1. We shall see that. So a, here a stands for a lower limit. So here we shall have the background of integration. A stands for lower limit, and that is what we call negative, positive infinity, negative infinity, and then b is our upper limit of the domain. Now, we use the second property, this property, to find the constants, because sometimes they give you, when they want you to find the constant. So to find the constants, one can use graphs, or one can use this property, whereby we shall be integrating to get the required value. So we are going to see how we use this second property to find the constants. Then we shall also be obtaining probabilities. Then after, we shall be finding parameters, the mean, the variance, standard deviation, quartile ranges, mode, etc. So in this lesson, we are going to find constants and probabilities. Then another lesson, we find the parameters. So examples. A random That is number one. A random variable x of a continuous probability density function is given by f of x. You need to always note we have a difference between small f and capital F, but we shall come to that. So f of x is equal to, we have kx at 0 less or equal to x less or equal to 6. Then we also have 0 elsewhere. Find the value of k. Remember, k is a constant. Solution to get the value of k. We said that, though this formula one may not quote it, but we said that from x is a up to x is b of f of x dx is equals to 1. No one can say all x f of x is equals to 1. So, meaning that the integral, since we have only one range, from 0 to 6, f of x, the function present at that interval is kx. Right? Dx should be equal to 1. So here, you should be able to know, or you should recall as far as integration. So this is a step awarded. Then now from there, you can factorize out a k. So you shall have k integral from 0 to 6 x dx is equal to 1. So k, now we integrate. When we are integrating, we increase the power by 1 and divide by the new power. So this is x, so it will be x squared, because it was x power 1. So it is x squared over 2. But because we have limits, we don't put a constant. We don't say plus constant, no. We instead put the limits. So it would mean that k, we first substitute the first limit, 6. So it will be 6 squared over 2 minus 0 is equal to 1 is equal to 1. So this is k. This is 36 over 2, which is 18, is equal to 1. So 18k is equals to 1. Therefore, k is equals to 1 out of 18. All right, so that is what we are having. When we start looking at examples, it is going to be very, very easy when we start looking for the parameters. So that is how we get a constant. Let's do another example where we have another interval, when the intervals are more than 1. A random variable x of a continuous PDF probability density function is given by f of x is equal to k x plus 1 for 0 less or equal to x less or equal to 4, kx just pick from this, so 4 less or equal to x less or equal to 6, and 0 elsewhere. Sometimes they put otherwise, find the value of k. In our solution, we shall note that integral all x f of x dx is equals to 1. All x, as if one says from a to b, okay? So it implies that the integral from 0 to 4, first, from 0 to 4 of the first function k x plus 1 dx plus, because there is another interval, so you have to also put this integral from 4 to 6 kx dx is equal to 1. So we can put out a k. So k integral of 0 to 4 x plus 1 dx plus k integral from 4 to 6 x dx is equals to 1. So integrate. So it will be k. We integrate this, it will be x squared over 2 plus, when you integrate 1, you get x. But the limits are 0 to 4 plus k. We integrate x, we shall get x squared over 2 from 4 up to 6. So here we can substitute the limits. So we shall have k. We first put the upper limit, it will be 16 over 2 plus 4. Then minus, we substitute a 0. When you're putting an upper limit, after substituting an upper limit, we now put a lower limit, and the lower limit being a 0, we shall substitute for 0 direct. So it is 0, this is also 0, so minus 0. Plus k, we put the upper limit, 6. 6 squared, that is 36 over 2. Then we subtract, when we put a 4, it will be 4 squared, which is 16 over 2. This should be equal to 1. This should be equal to 1. So this is a k. This is 8 plus 4 plus k. This is 18 minus 8 should be equal to 1. So this is 12k plus 10k is equal to 1. So this is 22k is equal to 1, giving you k as 1 over 22. So that is how we get a constant. That is how we get a constant. Let's look at how to find the probabilities now. Finding probabilities. Finding probabilities. Finding probabilities. Now, when we are finding probabilities, we integrate the function given for a given limits of probability. So I can say this involves integrating the function given for a given limits, for given limits of the probability. Examples. Examples. Number one, given a continuous PDF as f of x is equals to 1/18x for 0 less or equal to x less or equal to 6 and 0 elsewhere. Now here it is very clear because we don't have any constant to find, but sometimes they give you a question with the constant find first, then after finding the constants, after finding a constant, then you continue. But since we've already seen how we get constants, that's why I've opted to substitute the first constant which we got as our function. But we shall be doing many guiding examples that involve us to find the constants first. Okay, those are very common. So we shall do provided we first finish this struggle of getting the probabilities, then we shall be doing a general question. So find Roman 1, probability of x greater than 2, Roman 2, probability of x less than 3, Roman 3, probability of 1 less than x less than 3. Remember, we said that this is equal to, in our introduction, it would be 1 less or equal to x less or equal to 3. So we shall take on the whole range. Okay. Then for probability of x greater than 2 given x less or equal to 4. Solution. Roman 1. Probability, since we don't have any value of a constant to find, it is already given. The constant, it means it would be 1/18. Sometimes they can put for you kx and they say find k, then find these probabilities. So it means after getting the k, you substitute it. You substitute it and then you continue. Probability of x greater than 2. If x is to be greater than 2, then you need to locate, because you cannot integrate with only one value. You cannot integrate with the only one value 2. No. You have to integrate from a certain interval to a certain interval. Now, since you have 0 to 6, and then I've said x greater than 2. So you should not go beyond this 2. Sorry. That the value of x should be greater than 2. It means that 2 is the lowest interval. Okay. P is the lower interval. Then now we shall move up to 6. You need to observe that x must be greater than 2. So our upper limit is supposed to be greater than 2, meaning that 2 is our lower limit. So this is the same as the integral from 2 to 6. You cannot say 2 to 4, 2 to 3. No, you have to move within this. unless they define for you an interval like here, where they say 1 and 3. But otherwise, you have to be smart. So 2 to 6 of 1 over 18x dx. Okay, so this is the same as 1 over 18 integral from 2 to 6 x dx. So this is the same as 1 over 18, integrate that. You get, when you integrate x, you get x squared over 2, but from 2 to 6. So this is 1 over 18, substitute for x as 6. So it will be 36 over 2, because we shall square 6 over 2. So it is 36 over 2. We subtract when we substitute for a 4, to be 2 squared over 2, which will be 4 over 2. So the answer would be, this is 8. No, this is 18 minus 2. Right, so it is going to be 1 over 18 into 18 minus 2. 18 minus 2, that is 16. So by 2, shall have 8 out of 9 as our probability. Roman 2 needs us to get probability of x less than 3. When they say less than, it means that the upper value is 3. So if the upper value is 3, then it means that you had started from 0. Because now, if the upper x less than 3, it means that we shouldn't go beyond 3. And we have to be looking at this interval. So it means that we started from 0. So it is the integral from 0 to 3 of 1 over 18x dx. So this is going to be 1 over 18 integral from 0 to 3 of x dx. So this is the same as 1 over 18 x squared over 2 after integrating, then from 0, of course, to 3. So here you can substitute very well the limits. So if you substitute the limits, it is going to be 1 over 18, you put 3, so it will be 3 squared, which is 9 out of 2. So you're going to get 9 over 36, which is a quarter. For Roman 3, probability of 1 less than x less than 3. We say that this is the same as 1 less or equal to x less or equal to 3. And then when we are integrating, it's going to be the integral from 1 to 3, because there you're given direct range, 1 to 3 of 1 over 18 x dx. I guess this is very, very, very clear, simply because these conditions are the ones that you should first master when they say greater than, less than, and when they give you the whole range. Okay, so 1 to 3 of that. So this is the same as 1 over 18. When you integrate x, you get x squared over 2, but from 1 to 3. So this is 1 over 18. Substitute 3 first, it will be 9 over 2, because I'm squaring it, then minus, we substitute 1, it will be a half. So it will be 1 over 18 into 9 minus 1, that is 8 over 2, which is 4. So it was 4 over 18, which gives you 2 over 9 when you divide through by 2. So 2/9. Then now we go to this. We go to this. So probability of x greater than 2 given x less or equal to 4. This is the same as probability of x greater than 2 intersection x less or equal to 4 over probability of x less or equal to 4. Okay, so probability of x less than 2 intersection x less or equal to 4 shall take on this interval of 2 to 4. So it will be 1/18 integral from 2 to 4 of x dx over x greater than less than 4. It means that the upper is 4. So we shall say 1/18 integral from 0 to 4 of x dx. Right. So this is the same as 1/18 integrate x squared over 2 from 2 to 4 over 1/18 integrate, you get x squared over 2 from 0 to 4. It's the same as 1/18. If you substitute a 4, it will be 16/2, which is 8, minus 2 squared, which is 4/2, which is 2. Over 1/18 integrate, I'd rather substitute, it will be 16/2, which is 8, minus, when you substitute 0, it will be 0. So it is 4 it is 4/18. No, 6/18 divided by 8/18. So this is the same as 6/18 times 18/8. This one will go with this. So let me come here. So it will be 6/8. When you divide by 2, it will be 3/4. So that is the probability that you expected to get. Okay, let me do you another example for finding probabilities. A continuous random variable has a PDF f of x is equal to a quarter x for 0 less or equal to x less or equal to 2. Then we have a quarter 4 minus x for 2 less or equal to x less or equal to 4, and 0 otherwise. Part A of the question, show that the distribution is a PDF. B, find Roman 1, probability of X less than 1. Roman 2, probability of X greater than 3. Roman 3, probability of 1 less or equal to X less or equal to 3. Roman 4, probability of X greater than 1, greater or equal to 1, given X less or equal to 3. Solution part A. To show that it's a PDF, since they told me that it's a continuous, so I will note that for a continuous function, to be a PDF, the integral from negative infinity to positive infinity of f of x dx should be equal to 1. So I'm trying to prove if whether this one would be equal to 1 after integrating. So this would mean that I'll start from 0 to 2, so it would mean that the integral of a quarter x dx, I'm finding the integral of a quarter x dx from 0 to 2 plus the integral of a quarter 4 minus x dx from 2 to 4. This is 0 to 2, this is 2 to 4, right? So this is the same as a quarter outside being a constant. So when you integrate, you'd have x squared over 2 from 0 to 2 plus a quarter outside. When you integrate here, when you integrate 4, you get 4x. And when you integrate x, you get x squared over 2. So minus x squared over 2 from 2 to 4. So when you substitute in the limits here, you'll have a quarter then this is it, 4, because it is 2 squared. So 4 over 2 minus, when you substitute a 0, it will be 0, plus a quarter. First substitute a 4. When you substitute a 4, it will be 4x, which is 16, minus 4 squared, 16 over 2, that is 8. Then minus, you substitute a 2, it will be 8, minus 2 squared, that is 4 over 2, that is 2. So I want to see if this one reduces to 1. So this is a half this will go with this, so we have a half shall have a half plus a quarter into, this is 8 minus 6, which is 2. So this is a half plus a half, which is equals to 1. So the fact that the integral, since the integral of negative infinity to infinity of f of x dx is equal to 1, then the distribution is a PDF. As simple as that. Then for part B, they want us to find the probabilities, and they have begun with a probability. I think I can squeeze it here. Then I continue. So part B, Roman 1, probability of X less than 1. Now to get probability of X is less than 1, less than 1. It means that we shall start from somewhere, we end on 1. So we shall take the first one only, because when you go to the second function here, a quarter 4 minus x, it means that you have gone to 2. So we have not to go beyond 1. So meaning we shall keep ourselves limited here. So this is going to be the integral of a quarter from 0 to 1 of x dx, which is the same as a quarter x squared over 2 from 0 to 1. So when you substitute, it will be a quarter into, when you substitute 1, it will be 1 squared over 2, which is a half, minus when you substitute that, you get is 0. So it's going to be a quarter times a half. So the probability is 1/8. All right, the probability is 1/8. Then 2, they want probability of x greater than 3. X, if x is to be greater than 3, it means that you start from 3, you end somewhere. So it will be 3 to 4. Now don't come to the first range. It will be 3 to 4. Okay? It will be 3 to 4. So we shall say that the probability of x greater than 3 will be equaling to integral from 3 to 4. Now you take the range where these values are. So it will be a quarter being a constant out. Then I can say 4 minus x dx. So this is going to be a quarter. Integrate 4, you get 4x minus x squared over 2 from 3 to 4. So substitute, shall have a quarter, 4x, that is 16, minus x squared over 2, that is 16 over 2, which is 8. Then minus 4 times 3, that is 12, minus when you substituted 2, 9 over 2. So this one will be a quarter into 8 minus 24 minus 9, that is 15 over 2. So this will give 1/8. You can substitute, you can work out the LCM and then you multiply a quarter, or you can factorize out a half, so that it becomes 1/8 into 16 minus 15. So it will still give you 1/8 also. You just need to know the range they've given you and the functions you're going to use. But when you go to part 3, part 3, they want probability of 1 less or equal to x less or equal to 3. But remember the function they gave us 0 to 2, then 2 to 4, meaning that here we may take on all the intervals. So we are going to begin from 1 to 2, then we begin also from 2 to 3, because we have to end here. You're given the function, let me record it here. F of x is equal to a quarter x, this is from 0 up to 2. Then you're given a quarter 4 minus x, that is 2 up to 4. So if they want 1 to 3, for this case where you're given 2 intervals, if it was 1 interval, you're going to consider the interval from 1 to 3. But these ones being 2 different intervals, and you're having 1 to 3, it means that 1 will be found in this. Then the 3 one will be found in this. So it will be the integral of a quarter, okay? We shall first move from 1 to 2, from here, from 1 to 2, because we are supposed to begin from 1, but up to 2, then over quarter x dx plus a quarter integral. Now, since we are moving up to 3, we shall move from this 2 to 3 of the range that has the interval of 3. So that is 4 minus x dx. So you integrate normally. You're going to have a quarter. This is a repetition. It will be a quarter x squared over 2 from 1 to 2 plus a quarter 4x minus x squared over 2 from 2 to 3. So when you substitute, you get I want everyone to compute. It will be a quarter 2 squared, that is 4 over 2 minus 1 squared, that is a half. Then my minus, that is 1. Then plus a quarter, we substitute for 3, so it will be 12 minus 9 over 2. Then minus, substitute at 2, you have 8 minus 4 over 2, which is 2. So here we shall have a quarter 2 minus a half. 2 minus a half. If you have 2 minus a half, have 4, that is 3 over 2, right? So 3 over 2 then plus a quarter. Here we shall get 7.5, then minus 6. So this is 3 over 8. So I can say this is a half times 1.5, or sorry. This is a quarter times 1.5, right? Plus a quarter times 1.5. So this is a quarter into 1.5 plus 1.5, which is a quarter into 3, which is 3 quarters, which is 0.75. Finally, want us to find the probability x greater or equal to 1 given x less or equal to 3. This is going to be probability of x greater or equal to 1 intersection x less or equal to 3 over probability of x less or equal to 3. So this is, for this particular case, for the denominator it will be, for the numerator it will be probability of 1 less or equal to x less or equal to 3, okay, over, to get probability of x less or equal to 3, it's the same as 1 minus probability of x greater than 3. Okay. Yeah. So since I already have all these, I'm just going to substitute. What does it mean? It means that if you get probability of x greater than 3, you add probability of x less than 3, you should be able to get 1. So probability of x greater or equal to 3, the same as 1 minus probability of x less than 3. So this is going to be 0.75 over, because this one I've already gotten it as 0.75 in the previous part. Then 1 minus probability of x greater than 3 was 1/8. So it's going to be 0.75 divided by, this is 7/8. So this is the same as 0.75 times 8 out of 7. Okay. This one gives 6/7. Can stop it there, or can give it as 0.857. So that one works. So that is how this that is how we find the probabilities. And now our next lesson, we are going to look at finding the parameters, the mean or the expected value, the mode, the median, the quartiles. Yeah, so that is what we shall now look at in our other lesson. Get you there.